our final talk on the water-energy nexus is fittingly jointly presented by Timo Paul, who is a project manager with Vattenfall, and Heinrich Gürtler, an R&D manager at Berliner Wasserbetriebe, the local water utility. Guys, thank you for being on the program. We look forward to your insights.
Yes, thank you for having us. Yeah, I'd like to start. I share my presentation. Today, Timo Paul and I will focus on like one little topic in the water energy nexus, but if we look at the urban heat transformation and the transformation of energy supply, it plays a relevant role in urban areas and also in peri-urban areas. First of all, my name is Heinrich Gürtler. I work at the Research and Development Department at Berliner Wasserbetriebe, and I'm talking today about the potential of wastewater heat and how we tackle this topic in Berlin. And then Timo Paul will make a deep dive into one project we do together at Ruhrleben. And that's basically also the table of content. I will introduce the technology and present some content from some research project we did here, and then Timo Paul will present the project in Ruhrleben. First of all, why can we use wastewater for heating and cooling process? Because in the heating period, wastewater has a temperature around 12 to 15 degrees, and that's very suitable for the utilization with heat pumps. And as we see in this picture here, the wastewater flows through the sewer system and can be extracted by heat exchangers, such as painted out here, especially for heating and cooling of buildings or for low temperature or low X district heating grids. And how is this heat extracted? There we basically have two technologies we use in Berlin. We have already 25 projects in implementation or planning, and that's the two technologies we mainly use. In the sewer system, we see these plate heat exchangers that are based on the base of the sewer, and the wastewater flows over this heat exchanger, and in between these plates there is a fluid, it's water in our case, which extract the heat from the wastewater, which is then used by the heat pumps. In Berlin, we also have a big grid of pressure pipes, wastewater pressure pipes or pressure mains. And there we have a really simple form of heat exchanger. Basically, it's just two pipes inside each other, and in between we have this circular gap where the fluid from the heat pump can be and extract the heat from the wastewater, which is flowing inside the inner pipe. If we look where we can use the wastewater heat, it's basically in the sewers and pressure mains. There are also technologies that use heat pumps inside the buildings, but there we have little amount of wastewater and also discontinuous amount of wastewater. And also the sewers and pressure pipes are spread around the whole city, so we can cover a big area to use this technology. Some marginal conditions are that the sewer has to be big enough. We have to have a decent dry weather flow, more than 15 liters per second. And in the sewer and pressure pipe grid, we can't cool the wastewater more than 3 Kelvin, because then we affect the wastewater cleaning on the wastewater treatment plant. And that's how we can easily calculate the potential based on basically the flow. What we did in Berlin to unleash the full potential is that we wanted to show the potentials GIS-based. So we set up a research project and talked a lot with our operational staff and set up a GIS model that is processing data and calculations to develop a wastewater heat potential map, such as shown on the right side here. And therefore, we set up big simulation models based on wastewater billings for industrial inflow and census data and pumping data for municipal inflow. And so we had the wastewater flow in the city in similar and sewer and pressure pipe simulations. And then we did some interviews with our operational staff to get the pain points with its technology, because every object in the sewer affects the operation of the sewer, and so we wanted to just show this potential where we can use it safely without affecting the operational stuff. And so we did interviews and collected data on Berlin-wide and fed that into this GIS model. So we could set up the wastewater heat potential map, which looks like that. And it's not just the map. There are several insights of GIS data and also the potential heat capacity that we can extract from the sewer. Some insight on the sewer system, what kind of sewer system do we have, of course the simulated hydraulic data like dry weather flow and levels, and also the operational data like sewer cleaning demand or constructive conditions, renovations. This especially is important because if we combine construction of pressure pipes or sewers that with the implementation of a heat exchanger, we can lower the costs massively. And last but not least, I want to show you how we can use this potential data set in the urban heat planning, and that kind of unleashes the whole potential of this map. Because if you see here in the last year, we did some workshops and meetings with other big infrastructure companies in Berlin, like Vattenfall, like Gazak, like Deutsche Bahn, and we looked at their addresses and like their potential implementation sites. Like Vattenfall gave us, we have this project here and here and here, and so we could feed this data into our GIS system and do an analysis where we can find the interesting and suitable projects. And from this 2,000 address points, there are like about 500 in the potential area. And from that, we can also extract 20 interesting projects. So if you compare that to if every company comes to us with their addresses and we have like 2,000 potential projects, that would be enormous effort for us to analyze this. And with this tool, we can reduce the effort to 20 projects. And with that, I want to hand over to Timo Paul, who will present one extraordinary, interesting project to us, and he will take the presentation. Thanks.
Thank you very much, Heinrich. So maybe you will question yourself why two different companies will do that presentation. The reason is that Vattenfall in Berlin is the largest district heating provider and operator. So we are always in search of potential heat sources. And there's in the project I will show you, there's one thing mainly completely different, because what Heinrich was showing was mainly heat source on the dirty. Do I share the wrong screen, or? Let me check. Sorry for that. Okay, thanks for the hint. So now it should be the right presentation again, right? What Heinrich mainly showed was the heat potential on the dirty side of the water. The project I'm showing is mainly the heat which we use on the clean side of the sewage or clean wastewater. This is a project where I'm the project manager, and it started mainly 4 years ago, where we had the first discussions together with the Berliner Wasserbetriebe, how we can create an interface to the sewage water treatment plant the Berliner Wasserbetriebe has in Spandau. So this is more or less the largest sewage treatment plant in the western part of Berlin. This is located in the northern western part of Berlin. And what you can see here is that here is the largest heat production facility of Vattenfall in the western part of Berlin. So that is pretty close from a geological position. And the Berliner Wasserbetriebe, they needed to build up new cleaning facilities. So that was our, let's say, one-time or possibility once in a lifetime to create these interface. So we signed contracts 3 years ago. And the idea is that before the cleaned water will be distributed in the River Spree, that via an underground pressure pipeline, we will pump the water onto our facility and then use heat pumps to just cool it down. And then mainly also what we did already is to start the first constructions last year, because it's a quite complex project between both sides. I mean, on the one side, it's all the construction going on the sewage treatment plant, and it needs to completely align with our time schedule. So what we did last year is to lay down already the first 260 meters of the sewage pressure pipeline directly on the wastewater treatment facility. And so which means it's around from here, let's say, to that location, and the next step will be for the next around 600 meters below ground to build the next pipeline, which I will go on the next slides later on. So what is mainly the process we want to use? So which you can see here, you have more or less the sewage water treatment plant, right? Where the sewage water goes in, will be cleaned, and then normally, depending on the time of the year, it will be distributed in the River Spree with the temperature, let's say in the winter time at around 12 degrees C, and in the summertime it can go up to 27 degrees C. So what we did is to build up pumping stations and an interface so that we can extract of up to 1,500 liters per second with the corresponding temperature we have then, feed this into our heat pump system. Actually, we will have 4 different units on site. Then we will cool it down, and that depends, of course, on the surrounding conditions. So what is really the temperature of the wastewater? What is the temperature of the River Spree? Because we will distribute it later on in the River Spree. So our goal is, let's say, during winter time, to cool it down to around 3 degrees C. So if we will get it with 12 degrees C, we will cool it down by 9 Kelvin. And in summertime from 27, let's say normal operation would be to cool it down by 10 Kelvin, but the unit is able to cool it down by 15 Kelvin. so that we can extract much more heat out of the water. What we do then is to push the heat up to a higher temperature level, put it into our district heating system, which will be during summertime around 80 degrees C and in the wintertime 95 degrees C. Then, of course, it will be mixed with other different heating facilities, distributed to our customers. They cool it down to around 6 degrees C, and then the cycle of the district heating water will begin again. So that's an actual design of our current project. Honestly, the project started officially around 4 weeks ago. So there's nothing to show on site already. But let's say we build a completely new building to implement then their 4 different heat pump units. Each has a size of, let's say, a thermal capacity of around 18 megawatts with around 18 tons of refrigerant. The units will be connected so that we have one string on each side of the building, so which means each strings are parallel, but there will be 2 in one row. The corresponding COP in our design point is close to 3. It will be a little bit lower during cold winters, and it will be a little bit higher during hot summers, of course, due to the lower temperature difference between the heat source and the final heat then. So as I said, that in design point, we try to cool down the sewage water by 10 Kelvin, and this will lead then in design point to around 75 megawatts of thermal energy we put into the district heating system. What really is a big issue for the environment is that normally the Berliner Wasserbetriebe will distribute their water without cooling it down into the river. So which means either in winter time or in summertime, we will always cool it down. So we do a good part for the environment and the River Spree. And let's say old calculations have shown in our business model that we will produce around 400 gigawatts of thermal energy, which means that we can support around 45,000 households with the heat only out of that unit. And that will save, in a comparison to an old technical setup of heat production units in the city, of around 50,000 tons of CO2 per year. So just coming back to the time frame where I said that 4 years ago we started already the first ideas and negotiations, and then the question, why are we just starting right now? That's because there have been a lot of challenges to solve. One thing, of course, was to sign the final contracts, which happened then after 1 year of negotiations. So in August 2020, we signed 2 different contracts for that. And then afterwards, we needed to go to the authorities for all our permit applications. And then there was one big challenge, that there is no regulation available for what we are doing here, because we are no sewage treatment facility. So what kind of legal requirements needs to be met? There was a very constructive but long alignment, which led to the permit applications finally between October and December 2021. And as you can see here, nearly 1 year later, we received the first out of approximately 7 permits. The last one actually we received in August this year, so more or less 2 years only in the permit application process. So that was a challenge. Then, of course, we started our EU tendering for the whole project in November 2021. We sent everything out, but the first negotiation started in beginning of March 2022. So, which means geopolitical situations had dramatically changed at that time, which also made that very complicated. But nevertheless, in October this year, we finalized everything. the budget was completely internally released. So that means we started the project. We did our first test piling last month. We will put down the first piles into the ground in approximately 4 weeks. So planning is going on. Then beginning of 2025, the main components will be delivered on site. And then if everything works out and according schedule, we will try to finalize the whole project, including warm commissioning, approximately in September 2026. So that's from my side. Thank you very much for your attention. And I just wish you still a lot of good discussions today.
Yeah, I appreciate that. Thank you so much, Timo and Heinrich. And I do want to take the opportunity to ask each of you a quick question. If you could make your answers brief as well, that would be greatly appreciated. So Timo, rumor has it that the heating arm of Vattenfall is about to be remunicipalized. What, if any, role does that play in your planning? Is there any strategic advantage or challenge related to this?
That's a good question, and yes, rumors are true. Sorry for that. Rumors are true, but that will have no influence within that project. I mean, that's the good part. What I said that I mean these negotiations. I think they started half a year ago. But still, the whole project budget is released last month, so we are completely going ahead. And the reason why we do that is to get out of the coal, to do our coal phase out till 2030, and then becoming fossil free, hopefully till 2040. So it will be the same strategic, even if we will be municipalized.
Great, thank you. And this one is for you, Heinrich. I'm relaying a question from Reza Kayat Mogadam, who is wondering regarding the heat exchangers that you talked about. How do you control the massive fouling taking place in those exchangers?
The massive fouling, did I understand that? Okay, yeah. There is influence of fouling, of course, in the heat exchangers. But as we are in an infrastructure where we can't clean regularly, there's just a tackling of over-dimension of the heat exchangers. So especially in the sewers and pressure pipes, they just built the heat exchanger, like I think 1.5 times higher than dimensioned, and so the fouling factor is already included.
Okay, all right. Thank you so much. I really appreciate it.